title of this idea is the indigenous development of split Hopkinson reservoir. I am Dr. Vijayasimha Reddy, the principal investigator of this project. Briefly, I would like to give the introduction that all engineering materials have to be characterized for mechanical properties such as modulus of velocity, yield strength, fracture toughness. But all our conventional determination of these material properties using laboratory equipment like quasi-static tests in our hydraulic machines will be of very low strain rates. So usually in the order of 10 to the power of -4 to 10 to the power of 0 per second. But the material response depends on the rate of deformation. Its seemingly slow rates of loading, the rates of deformation can be very high locally. That means in the order of 10 to the power of 3. So knowledge of material behavior at very high strain rates is very essential, because in most of the aerospace applications and high-speed collisions, so it is very important to diagnose the material properties, because the material properties vary with the strain rates. So, for example, yield stress of mild steel doubles at a strain rate of 40 per meter per second. But as yet, there is no standardized quantified data which is available for yield stress, and only for few materials is available. Therefore, high strain rate data for modulus and fracture properties are not available for any materials. So therefore, the investigations are very much needed, hence the newer equipment to test this. So in this direction, we have a reference material, a reference equipment called a split Hopkinson pressure bar, so which was designed by the Hopkinson in 1914, and later it was modified by Polsky, and which is called as split Hopkinson pressure bar, which is highly useful for measuring the dynamic stress strain response of the materials. So the majorly the equipment consists of a gun barrel, which is launching a projectile, which is called as a striker bar, and has an incident and a transmission bars. This specimen whose properties is to be tested is sandwiched between the incident bar and the striker bar, and a high velocity launcher strikes the incident bar, and the stress wave travels through incident bar, the specimen and the transmission bar. So we will get the voltage time signals of all the three. So the So this is the typical model of our idea which has been built, which is operational, and this equipment consists of a launching bar with a striker bar which is housed inside, and you have an incident bar. This is an incident bar. This is the transmission bar which is coaxially aligned, and the specimen whose properties have to be tested is kept between these two bars. So when a high velocity jet of air through a compressor is released here, which is the energy for launching the striker bar, which strikes the incident bar, and then the input energy is transmitted to the specimen and to the transmitted bar. Now here we have instrumented these two bars with the strain gauge, and which in turn is connected to the strain gauge amplifier and also the software for processing and to get finally the stress strain curve. So initially we get the signals, the voltage time signals, which will be converted into force time and displacement traces, and these in turn are interfaced to give the load displacement to the stress and strain curve, which is essential to calculate the Young's or material properties of this material. So mainly, the varying the velocity, we can vary the strain rates. So these strain rates can be achieved up to 10 to the power of 3 in this mechanism. So we can achieve strain rates of 10 to the power of 3 per second. So this is the objective of the work. So let me demonstrate to you with a typical experiment. So here this is the valve which is connected to the cylinder through which I am giving the air input so that the striker bar strikes this one. So just switch on this. So this is the specimen which is kept between both the incident bar and the transmission bar. You can see the small disc of aluminum which is kept in between these two, whose properties can be determined. So now just put it. So this is what is once now with the high velocity striker bar strikes the incident bar, and also the signal transmits through the specimen, and the difference in the energy levels of the input and output bars is measured through a voltage time oscilloscope, and the difference in these two energies is the energy absorbed in this material. So therefore this can be characterized by using stress strain curve by processing this voltage time signals to load displacement curve and then stress strain curves. So we have a lot of instrumentation for this, and also processing software which is required to complete the processing. So hence we can evaluate the yield strength of the material, we can evaluate the fracture stress of the material, and also Young's modulus of different materials at a very high strain rates, which is very uncommon in any equipment to determine. So this is the uniqueness of this equipment. Now we need an oscilloscope, we need a high level, then high rate data acquisition system in the order of 2 giga samples per second.